So I'm very happy to be here. It's my third OpenStack day in Budapest, second time speaking. So it's always a great event and great community vibe. I really like it. So my name is Thierry Carrez. I work for the OpenStack Foundation. You can find me on Twitter. I recommend usage of Twitter because apparently our president in France is a rock star. So today I want to talk to you about what makes OpenStack relevant in a containers world. What does OpenStack bring to a containers world? Because every now and then a new technology appears, and as it appears, it creates a lot of confusion about what exact use case it fits, and people try to wrap their heads and their strategies around that new technology, and it creates, at that point, a lot of confusion. It was OpenStack in 2011 when it reached the spotlight. It was containers in 2014, it was Kubernetes in 2016, and every single time, everyone wants to believe that this new technology will replace everything else, that will be the technology to end everything forever. Because it's so much more convenient to think that you will be able to learn one single technology and be done with it, because it will be the answer to all the questions forever, and it will replace everything else. So the rise of containers and container orchestration engines created a lot of confusion, especially with respect to OpenStack. If containers are replacing VMs and OpenStack is about VMs, does that mean that OpenStack is not relevant anymore? Or if I just want to do cloud-native applications, why would I go through the hassle of considering OpenStack? Or and even for those who actually got that those were different technologies, that one would not necessarily replace the other, there is a lot of confusion around whether OpenStack runs on top of containers, or containers run on top of OpenStack, or both, or whatever. And those are not theoretical questions. That's questions I've been asked all the time. I've been going to several container-oriented conferences over the past year, and those questions come again and again. And to help answer them, I want to introduce a cast of characters that will help us through clearing out that confusion. Personas are tools that are used in user experience studies, where you basically define a profile, you give them a name, a story, try to get people to relate to them, and then you use those to frame the discussion and explain what the various stakeholders think about the given problem. So I want to introduce three slightly overlapping personas. The first one, let's call him Dinesh, is the application developer. So Dinesh writes the apps that sustain your business. He cares a lot about speed, so speed to design, speed to write code, speed to deploy, speed to market from when his boss asks him to do something to deployment. Dinesh likes to use the latest shiny technologies because that makes him efficient, so that makes him quick, but also because that makes him that keeps him on the edge and makes him ever relevant on the job market. Today, that means Dinesh likes 12-factor applications and serverless and stuff like this. Dinesh doesn't want to care that much about infrastructure because he doesn't want to deploy servers, doesn't want to have any differences between development, test, and production environments, introduce new bugs in his applications. And finally, Dinesh is very happy does not obsess too much about cost or lock-in. So he's very happy to use Amazon Web Services. He finds it very convenient. It's like the candy store. Our second slightly overlapping persona is, let's call him Bertram, is the application operator. Is the person who handles the deployment, the monitoring, and the scaling of your applications. In Google parlance, it would be like the SRE. He cares mostly about performance and scalability. He's on call, so he really likes solid and proven tools that will not break on a Sunday. While he does not want to micromanage infrastructure, he still wants to be able to look under the hood. Still wants to understand how everything works and be able to actually understand optimize the technology for his specific use case. Bertram is concerned about lock-in because, again, he likes to pick the best technical solution for the job, and locking is reducing his options. The third persona, slightly overlapping again, let's call him Ehrlich. Ehrlich is the infrastructure provider. As it happens, even in serverless, someone has to rack servers, and that's Ehrlich's job. So Ehrlich could operate a public cloud and offer infrastructure resources to anyone around the world with a credit card, or he can operate more of a private cloud where he can offer infrastructure resources within a given organization. Ehrlich doesn't want to care too much about specific workloads or applications. He sits at the opposite spectrum of Dinesh. Is only interested in providing generic workload services so that Dinesh can deploy any type of app on top of it. But he wants to be able to ignore what type of applications actually are running. He cares a lot about cost of operations, actually is primary metric, because that's what it does. Like it has to provide infrastructure resources for the best cost. He also cares about evolution and his ability to evolve that framework he will deploy to meet the needs of his users. Okay, so that's the cast of characters that will illustrate what I'm saying next. Now let's introduce the various technologies there. I assume you already are familiar with OpenStack, so I'll just jump to clearing out what containers and Kubernetes and that kind of stuff is. So first, containers. What are containers? Well, containers are two things. It's first a packaging format. It's a very nifty way to package an application together with its dependencies and libraries and in a very self-contained package. Second, it's a very convenient deployment tooling, a set of tools that make it really easy to run your application in a relatively isolated environment. And the success of Docker comes from taking those key kernel technologies, namespaces, control groups, and wrapping them into convenient tooling that makes it really easy to use. Now, with the success of containers, Docker also turned into like a marketplace of packages. Like you have a lot of companies that are publishing their application stack under a container form in the Docker Hub. So if you think in Debian terms, that's a combination of the deb packaging format, the apt-get tooling to deploy those packages, and the Debian repositories that let you have this marketplace of packages. Okay, as such, containers are extremely appealing to Dinesh, right? Because Dinesh can package his application together with all the dependencies. He can isolate his application from the operating system intricacies, and he can make sure that his environment will look the same in development, testing, and production. So that reduces all the problems that it might encounter when people try to deploy his application. Now, Kubernetes. Kubernetes is one abstraction layer up from containers. It lets you describe groups of containers called pods, the role they have in the system, how you scale them, and then have it deployed semi-automatically and maintained like magically. In a way, it's a deployment platform for containerized applications. What really makes it great is that it encapsulates operational best practices originally out of Google, drawing from Google's experience and bake them into the tool. It's also pretty good at managing application lifecycle. So things like handling rolling upgrades are also baked in the application. And as such, Kubernetes is very appealing to Bertram because it's pretty solid. It's designed around operational best practices. It's open source. You can run it on public or private cloud infrastructure, so it's not conducive to lock-in, so it limits his lock-in concerns. And so that makes it a really great tool for application operators like Bertram. So containers are for Dinesh. Kubernetes is more for Bertram. None of those are great for Ehrlich, though. What does Ehrlich want? Well, Ehrlich wants to provide generic programmable infrastructure. and he wants to give the Dineshes and the Bertrams in his organization or in the world access to it. At that point, Ehrlich has two choices. It can go specific infrastructure or open infrastructure. Specific infrastructure is the case where Ehrlich knows that all that Dinesh and Bertram will ever want is a container cluster. If you're sure 100% that your organization or your customers will ever need is a Kubernetes cluster, then yes, you should probably just go specific and deploy a Kubernetes cluster. Otherwise, you could opt for open infrastructure. Open infrastructure, what is open infrastructure? What do you want out of open infrastructure? Well, first you want options. You don't want to settle on one technology forever. You want to give Dinesh and Bertram access to containers, Kubernetes, but also other container orchestration engines, potentially like Mesos, but also virtual machines and bare metal machines, and you want them to be able to combine those into their applications. You want all those to be able to communicate and share through common storage and networking. You want to be able to compose those various technologies into a single application that shares networking and storage. You want to provide advanced services as well, like object storage or a database as a service, because people like Dinesh really like to have those high-level constructs to be able to build their applications on top of them. You want multi-tenancy so that groups can be properly isolated and accounted for. You want interoperability so that you are not locked in with a given provider. You want bursting beyond interoperability. You want bursting because you want to be able to use those public clouds, this capacity, for those very few moments or days that you actually need that extra capacity. You want the solution to scale to hundreds of thousands of CPU cores because you don't want to be limited. You want seamless operations, so you're interested in things like common log formats or common configuration file formats. And beyond that, you want to make sure that the solution you select will support whatever comes next, because you want the framework you deploy to support the needs of your users, the Dineshes and the Bertrams of today, but also the needs that they will have in the next future. You don't really want the near-term future. Don't really want to reinstall everything just because technology moved to something else, and now Dinesh wants to have access to something else. And that is all what OpenStack provides, right? Some people equated it to VM automation, but it was always more. OpenStack's goal is to help the infrastructure provider answer the needs of the application developer and the application operators. So it provides programmable infrastructure. You get VMs, bare metal machines, container orchestration engines, not just Kubernetes, but also others. You get open infrastructure, so you can actually plug more services into it as needed. It provides interoperable infrastructure, so you have existing public clouds from especially operators in Europe and some in the US as well, to be able to burst your capacity to. You want also future-proof infrastructure, a framework, not a product, that will integrate whatever technology comes next. So now that we've explained the technologies and how they fit, which exact target they have, let's see how those technologies can be combined. So first, you deploy OpenStack on top of a number of servers, which don't look like servers on this slide. Interesting. That's what you get if you use Unicode characters, I guess. So OpenStack on top of servers, small boxes there. So the first use case is you just want raw resources out of your OpenStack cloud, and you will deploy Kubernetes on top of it yourself, or containers directly on top. So you want VMs, a set of VMs, you want to deploy Kubernetes on top of that, and then you would deploy your containers. Well, if you want to do that, you will combine those, you would probably use those OpenStack technologies, like Keystone for authentication, Cinder for common storage, Neutron for common networking, Glance to catalog disk images, and Nova on top of that to give you the API to do the VMs. Give me a VM API. If you want bare metal machines instead of VMs, well, you just have to plug Ironic into that mix, because Ironic will let you drive those bare metal servers as if they were like VMs. So that's like the basic use case. But what you might want to have is you just want a Kubernetes cluster. You don't want to have raw resources that you will have to deploy your Kubernetes or another Kubernetes orchestration engine on top. So what you want is directly have Kubernetes cluster, because it's not necessarily easy to deploy. And so how would you do that? Like, and then you obviously deploy your containers in there. How would you do that? Well, you need 2 additional projects: Heat for orchestration and Magnum for this container orchestration engine provisioning part. And Magnum can make use of VMs or bare metal machines, so you might want to have Ironic in there, depending on your profile. So that's still a bit complex. If you just, all you want is just deploy a single container, like you just found this one on the Docker hub or catalog, and you just want to deploy that container, you don't really need a Kubernetes cluster. You don't want to learn about Kubernetes. You don't really want to deploy a VM and bootstrap a Docker runtime on it and then deploy your, how do you do that? Well, we also have a solution for that. So all you want to do is just throw a container to OpenStack. For that, you would use Zune, which is a very thin layer that will provision a VM or a bare metal machine with a Docker runtime on top of it, and then let you run that container there. It's as simple as Zune create the name of the container. It's like one line. And an interesting thing is that in all those cases, by virtue of running OpenStack, you have those solutions share networking and storage. So you can actually combine those and into networks that will be able to share. The application architecture can combine those technologies and share networking and storage. Like Kuryr exposes neutron network to the container and pods. So you can just reuse the neutron features in terms of network layouts. In the same vein, Kubernetes has native support for Cinder volumes, so they can be mounted directly onto pods. Last use case, that's more a future science thing. The project is called StackCube. It was previously known as Hypernetes, if you know the hyper container thing. So what they want to do is be able to run Kubernetes, but not reinvent networking or storage or identity management. What they want to do is a multi-tenant Kubernetes distribution. And Mark touched on that earlier. We want to make sure that they can reuse OpenStack components where they fit in that picture. You don't want like Kubernetes to reinvent Cinder. Like it's already there. Why would you go through the hassle of reinventing it? You have Kubernetes. You want to reuse Keystone for authentication and identity management. You want to reuse Cinder for volume drivers. You want to reuse Neutron for SDN. And StackCube actually sits between Kubernetes and those things. Make sure that you can reuse, you can deploy Kubernetes on top of those 3 OpenStack projects. Doesn't have Nova in there, just Keystone, Cinder, and Neutron. And the benefit is you get multi-tenancy, a true Kubernetes multi-tenant solution if you use their hyper container technology, which isolates inside VMs the container runtimes. So you get like a fully multi-tenant Kubernetes cluster out of the box using their distribution. They're currently hosted on OpenStack infrastructure and want to apply to become an OpenStack project. Okay, so we've seen how Kubernetes containers and OpenStack fit together. We can see how we can run containers and Kubernetes on top of OpenStack. But you probably heard that we can also run OpenStack itself on Kubernetes or containers. So like it's a bit Inception-like. How does that work? What is it true? Or why would I do that? Or why would I run Kubernetes on like OpenStack on top of Kubernetes and then Kubernetes on top of OpenStack? Doesn't make sense. Well, first, in that discussion, you have to realize that OpenStack is a complex application. It's actually lots of scale-out microservices. It's a lot of small bits that you can scale to meet the demand, like API servers. If there is a bottleneck there, you can add more of them, or compute nodes, you can add more of them. Deployment is therefore complex because there's lots of moving parts, lots of various micro tasks in an OpenStack cloud. Upgrade is also difficult, also due to the massive distributed nature of an OpenStack cloud, especially if you don't want to cut user access to the resources while you're doing the upgrades, which is usually what you want if you want to like deliver good service. So OpenStack is a complex app, and if you look at what those technologies provide, they might actually be a good fit. So containers, packaging format, convenient deployment tooling. Well, that sounds like it could be useful for deploying that complex OpenStack thing. It could be useful for Earlish to deploy that OpenStack thing. And so you can totally use containers instead of classic distribution packages. And you can also reuse that tuning to simplify deployment. So, and that's what we do. Like OpenStack runs in containers. We have like two solutions there. OpenStack Ansible is deploying OpenStack into fat containers using Ansible. Fat containers meaning they're like encapsulating the whole OS rather than try to be as small as possible. Cola, the original version of Cola, is deploying OpenStack in light Docker containers using Ansible as well. So those frameworks basically simplify deploying OpenStack by pre-packaging it into containers and then upgrading containers instead of individual libraries and services. Now, if we look at Kubernetes, it's a deployment platform for containerized apps designed around operational best practices, manages application lifecycle and scaling. Sounds like it could be very useful for that OpenStack application we have. So you could use a Kubernetes-based substrate and deploy OpenStack on top of that and simplify by that action scaling and rolling upgrades of OpenStack. It's a complex application, even for Kubernetes standards. It's like they have to push the boundaries of what Kubernetes is capable of to be able to deploy OpenStack on top of Kubernetes, but it's pushing the envelope in the right direction. If they basically can deploy OpenStack, they can deploy anything. So they're very interested in helping in supporting that specific use case. And we have a number of projects that look into that. So Cola Kubernetes is the Cola subteam that is working on an OpenStack deployment framework using Docker containers deployed onto a Kubernetes substrate, orchestrated using Kubernetes. And OpenStack Helm, I don't know if you're familiar with Helm. Helm is like, Helm charts are the packaging format for Kubernetes applications. So it's like you describe a collection of containers, you describe the pods, and it's just Helm install, blah, and it just deploys multiple pods into Kubernetes. So it's very promising, but it's very young. But we already have a group of people working on building OpenStack Helm charts for deploying OpenStack directly, Helm install Nova, basically, onto a Kubernetes substrate. So, in summary, containers are a packaging format with nifty tooling answering the needs of application developers. Kubernetes is a best practice application deployment system answering the needs of application operators. And OpenStack is an open infrastructure framework enabling all sorts of infrastructure solutions answering the needs of infrastructure providers. Those are three slightly overlapping personas, but still you have to really understand which technology is actually trying to address. You can run containers on OpenStack, provided infrastructure, allowing them to share networking and storage resources with other types of compute resources. You can run Kubernetes clusters can be deployed manually or through a provisioning API on OpenStack resources as well, giving their pods the benefits of that shared infrastructure. And finally, operators of OpenStack can leverage container and Kubernetes technologies to facilitate their deployment and management of OpenStack itself. In summary, in the end, they are really just different complementary technologies. So that concludes my talk. Thank you for your attention.